up on the screen is a little one screen full scheme interpreter. And this is the whole thing except for a few sub-procedures. And the few sub-procedures take up, you know, the first half of chapter 4. And to understand this, you look at the little binary tree over there representing the 4 kinds of expressions that exist in Scheme. And again, this is typical of any programming language, really. So the first kind is something that's self-evaluating. The canonical example is numbers, but also number sign T and number sign F are self-evaluating. And there are a few more things, more obscure ones that we haven't really looked at. The next kind, the other kind of atomic expression, atomic is just the opposite of list, something that isn't a list. The other kind of atomic expression is symbols. A symbol is something like hello, or X, or pi. And symbols are the names of variables. And so we evaluate them by finding out the value of the variable. And then there's 2 kinds of list expressions. And which kind it is depends on the car of the list. So if the car of the list is a keyword, that is to say it's one of the words define, lambda, set bang, if, cond, what did I miss? Define class, I guess, if you load the object system in. And or, thank you. Those are the keywords that name special forms, and there's fewer than a dozen of them. And again, every programming language has something like this, special syntactic forms. They usually don't look so much like procedure calls. You can see that, you know, they have braces in them and things like that. And in Scheme, a list that is not a special form is a procedure call. The difference between a procedure call and a special form, for our purposes, the basic difference is procedure calls are evaluated using applicative order, which means what? Hands up. Who can tell me what applicative order means? Yes? The arguments are evaluated first, yes. So we start by evaluating all the sub-expressions, all the elements of the list, and then we actually call the procedure with the argument values as its arguments. A special form is essentially normal order. The special form gets to see not the values of sub-expressions, but actually what you typed, the sub-expressions themselves that you typed in. And the special form gets to decide which ones it's going to evaluate in which order, and so on. And that's it. That's the language. OK, so as in the 2 previous evaluators, starting with the calculator one, there are 3 main procedures here. There's the read eval print loop, which says print the prompt, read an expression from the keyboard or whatever, from a file maybe, and then eval that expression. And in Scheme 1, it just said eval read. But now with the environment model, we know that you have to evaluate an expression in a particular environment. And for the ones you type in at the Scheme prompt, it's the global environment, always. So we eval whatever you type in the global environment, print the result of that, and then loop. So read, eval, print, loop, REPL. Eval, the structure of eval is a cond, because there are 4 kinds of expressions. So eval takes 2 arguments, an expression, exp, and an environment, env. We don't know yet what an environment looks like. if the expression is self-evaluating, then we don't even look at the environment. The value of 3 is always the same no matter what environment we're in. So we just return exp. If exp is a symbol, then we look it up in the current environment. So this is where you have to understand what you learned at the beginning of chapter 3 in the environment model, that an environment is a sequence of frames. So the current environment consists of the current frame, the one we just created for this procedure call, and that frame points to another frame, points to another frame, and eventually at the end you have the global environment. Everything indirectly points to the global environment, which doesn't point to anything. So an environment is a sequence of frames. We start in the first frame and look for the variable. If we find a binding, that's it. If not, we go to the next frame and so on until either we find a binding or we run out of frames. In the latter case, it's an error. So if it's a special form, which we tell by looking at the car of the list, at this point it's got to be a list. If it's a special form, then it says here, do special form. That's the big hand wave in this procedure that makes the whole thing fit on a screen. When we look at the real code in just a bit of the metacircular evaluator, there's a clause like this for each special form. So it says, is this an if expression? Then eval if exp env. Is this a define expression? Eval definition exp env, and so on. So each special form has its own rules, different from all the other ones. Else, if it's not any of those things, then it's a procedure call. This is a don't do any error checking approach. It could be something that's not a valid expression. Maybe you typed in close parenthesis or something. Or maybe you typed in a vector, not a quoted vector, just a vector. You said number sign, open paren, 567, close paren. Which a vector is not a valid expression in Scheme, although some Scheme dialects treat them as self-evaluating. That's not part of the standard. You can't really do it. So really we should say, instead of this else, we should say, is it a list? And if so, treat it as a procedure call, else error, invalid expression. But we don't do any error checking here. So what happens here in this else, these next two lines, are really the crucial thing in the metacircular evaluator, which is how we evaluate a procedure call. So how do we evaluate a procedure call? The first step, before we do anything else, is we evaluate all the sub-expressions. So right here, we're evaluating the first sub-expression, and that's the one that's going to tell us what procedure we're calling, right? Now, more than half the time, that expression is just going to be a symbol, which is the name of a procedure that we defined earlier. Either it's a built-in primitive procedure or you defined it earlier on. So evaluating the car of exp will boil down to looking up a symbol, which will turn out to have a value probably in the global frame. But sometimes what's in here is a lambda expression, or maybe it's a call to a procedure that you defined earlier whose value is a procedure, whose return value is a procedure. But one way or another, the value of this thing had better be a procedure. And here is where we're evaluating all the argument expressions. Okay, so cdr exp is a list of all the argument expressions. And this map is going to turn that into a list of argument values. I don't mean turn into as in mutate. I just mean create a list of values corresponding to that list of expressions. And how do we do that? We evaluate each sub-expression in the current environment env. So we can't just say map eval could/x the way we could in the scheme 1 interpreter, because eval now takes 2 arguments. Map wants a function of 1 argument, namely the sub-expression e. And so we have to say lambda of sub-expression, evaluate that sub-expression in the current environment. Okay? Having done that, we've now evaluated everything. Now we can call apply.